Hello, today we will learn about converting the decimal fractions to binary number representation. So for example, if we have 3/4 base 10, how would that look like in base 2? Similarly, if you have another number in decimal point, a fraction represented as a decimal, 0.8756 base 10, how would we convert that? And then another example would be a full number 10, or a number with a fractional part, not a zero in front of it, a number like 10, and then for example 10.762, how would we represent that in the binary number? And then we will also learn how to convert it back. So let's start with the easiest one. For that purpose, what I'm going to do is I am going to use Google Sheets later on in my exercise, and I will bring that in. But let's start with 3/4 base 10. So if we take this number 3/4, and let's say we know that it is equal to 0.75, right? So what we do is we take the 0.75, this number that we have in our hand, we multiply it by the base that we try to convert, which is 2, because base 10 is 2. So that number comes out to be 1.50, right? Now this one we separate it out because that is going to be first part of our binary digits after 0. So we will say 0, and then we put this one here. The remaining part, the one part that does not have the 1 after the 1, we take that. We take it 0.50, which is the part without the full number, multiplied by 2 again, and that comes out to be 1.0. So we take this part and we put it next to our number, and then since the fractional part is now only 0, so we stop here. Now sometimes we will keep doing it and our fractional part would never become 0, so we'll stop after a kind of a number of digits that we are okay. So what we get is 0.75 or 3/4. So we have 3/4, which is, if you represent as a decimal point number, is 0.75 is basically 0.11 base 2. Okay, so that's our first conversion. Now is it the correct number? Does it give you the 0.75? So let's try that. So we have numbers. How do we convert it back? We take 0.11 base 2. Now like we did before, we take our 0 is the full part, so we will treat it separately, and we divide the numbers where we have the fractional part and the full part. So this is our fractional part. We don't really care much about it because it's just 0, and we start with, now this is where the powers of 2 start going on, but these are power of 1, just like 1000, 1/10 we talk about in normal system. This is how it is. So this is 2 to the power 1, this is 1 over 2 to the power 2, and so on. This is a 2. So what we have here is, if I kind of write it again, we have 1, but this its place value is 1 over half, and its place value is 1 over 2 square, which is 1/4. Now 1/2 times 1 is 0.5, or 1/2, plus 1/4 value is 0.25, and if I add them together I get 0.75, right? Now if I was not adding it at like points and I want to add it as a fraction, I have half plus 1/4. So basically it is 2 over 4, just how we add fractions, plus 1 over 4, and I get 3 over 4. So we get our 3 over 4 base 10 back when we convert it back again. Okay, so this is how we convert a fraction. Now another example that I said we will do is 0.8756. So let's practice with me. So we take our number 0.8756. That is a base 10 number, and I want to convert it to a base 2 decimal number. Now this number does not have any number before the decimal point, so we are not worried about it. In the next example, I will show you what happens if we have a number before the decimal point. So an easier thing would be for me to bring in the Google Sheet to make my life little easier on multiplications. So what I would do is I will take the number 0.875, I will write it down, 0.8756, and I multiply this number by 2. Take this number and multiply it by 2, just like I did before. Now when I did that, I get, let me bring a little bit more of it, I get 1.751. Now what we do here is we take the integer part of it. So we will say only the integer part of this number, which is equal to 1. Okay, this will be going to be our first digit in there as we go from the decimal point. Then we will say here is we take our converted number, subtract the digit part like we did before, sorry, I think I did something mistake here. I will have this is equal to this number. Okay, I think I did some mistake in here. So this is equal to this number minus this decimal part. Okay, let me just write it down. That would be B1 minus C1, which gives me the decimal part. Now since I will be repeating the same things, I can drag this down. Here I get the same action, and I can take this whole process and I can keep repeating this whole process. And you can see that after this I have 1 1 1, and that kind of after that my numbers start becoming 0, and I get so I can have my decimal value come up to be 1 1 1. Now by hand, if I do that, it would be like this. So if I do it by hand, it will be, I'll take this 0.87562, 0.87556 multiplied by 2, and that would be equal to 1.7512. And what we do is we will take this part and we put it on the side. We will choose it, and after our decimal point we will put it here, right? And then we choose only this part. So from this whole number we subtract the whole part, and we get 0.7512 multiplied by 2. Now if you multiply it by 2, we can start from here. 2 times 2 is 4. 2 times 2 is 1, or sorry, 2 times 1 is 2, 2 times 5 is 10, so 0, 1 carry. 2 times 7 is 14, 14 plus 1 is 15, so we get 1.5024. Here again, we will pick up this number, put it in our conversion, and we take this leftover. We take this 0.5024 multiplied by 2, and that would be equal to 2 times 4 is 8, 2 times 2 is 4, 2 times 0 is 0, and 2 times 5 is 10. So I come up to 1.0048. What I would do is I will pick up this number and I pick that and put it in here. Now, if I so my remaining number here is 0.0048. It's not all the way to 0, but it's very close to 0. So I can decide to stop it, because that I will get 0.096. Again, my next number would be 0, and if I keep continuing, there would be smaller numbers comes in here. We will have to sacrifice some precision here. We can go further. For example, if I keep going in here for detail in here, we can go, let's see, we will start seeing some numbers in here. After a very long time we start getting, so it would be more precise, of course, you know, if we keep going in here, but this is 1 1 1 and then 1 2 3 4, multiple of zeros and then 1. So I will just say I am okay if I get this close. But when I convert it back again, 0.111, let's convert it back again. So only the digits after the decimal point, I have 1, a 1, and a 1. Starting from the top one, it comes over 1 over 2 to the power 1, 1 over 2 to the power 2, 1 over 2 to the power 3. Okay, so that will come up to be half plus quarter plus 1/8, and we get 0.5 plus 0.25 plus 0.125. Now if we add these numbers together, we get 5, then we have 7, and then we have 0.875. So this little 6 we lost in precision. If our calculations allow us, we can stop here, because it is hard to represent the decimal numbers into fractional number into binary. So we can say that approximately, so it's not exactly equal to, approximately equal to 0.111, and we can say up to 3 decimal point. So this is true up to 3 decimal points. So it's not all the way correct. It's only true up to 3 decimal point. Now the last one is easy. If I go back, which I say, if I do have a fractional part here, for example, and a full part, so 10.762, how do I convert that? So I put it in here. I say I have 10.762. How do I convert? For that purpose, I will convert this part separately and this part separately. So first I will convert 10. How do we convert 10? Sorry, let me write it here. I have 10. We just do our normal division, special division. It goes in 5 times and does not leave a remainder. We do it in here. It goes 2 times but does leave a remainder. We go again. It goes 1 time with no remainder. So what do we have in our hand? We started from here and then we go up like this. So we have 1 0 1 0 base 2. So that is the first part. That's the first part for 10. Now let's go for 76.762. How do we go about that? Multiply it by 2. So we get 4. 2 times 6 is 12. 1 carry. We have 1.524. So we'll take this number and in here our number after the decimal point number, then we will combine them together. We will put that in here and we take the remainder part, multiply it by 2. We get 8. 2 times 2 is 4, and then 10. We take this part put it in here. The remainder is 0.048. Of course, we multiply it by 2. It gives us 0.96. This part we take and put it into our then we take the 0.96. Depending on how far you want to go, how many decimal points you are okay. 2 times 6 is 12. 1 carry. 2 times 9 is 18. Plus 1 is 19. 1.92. We will take this number and we put that in here. So let's say we only want 4 decimal digits. So we have this represent our 10 and this kind of represent our, we could have gone further because then we will have 0.92 and we multiply it by 2. So we can keep going, but we are okay with 10 digits. So remember, what we have done is our base 10 in 10 is equal to 1010 base 2. And our number 0.762 in base 10 is kind of equal to, because we cannot say it's 100%, is 0.1101. Combining them together, we get our number 1010.1101 base 2. So that's how we convert the fractional decimal numbers into the binary number. Now if you like this video, subscribe, and in the comments tell me what would you like to understand. In the next lectures I am going to discuss about how do these numbers are stored in the computer. There are certain type of formats so that we can keep the number signs and numbers, precision as much as possible. So that would be in the next video. Thank you and see you then.